Hi, it's Michael with Gimbel Automation. I want to make a short video because I'm getting a lot of questions specifically about how we do one-op stock prep in an automated fashion. One-op stock prep is one of the easiest things to do where we're doing features like, either just squaring up stock, or the most common is actually putting a dovetail onto a piece of stock in order to, do say fifth or sometimes fourth axis work holding in a dovetail vise. Now we're able to do this with gripper automation incredibly easily. It's something that you can actually learn in an afternoon. As a company, we offer both hardware sales as well as turnkeys. And, among turnkeys, we're also able to offer what we call a semi-turnkey, where basically we're doing everything from the tray design to the soft jaw design to the entire workflow process and actually testing it and implementing it for you. So we can just ship you the entire thing, walk you through installing it, and then you're ready to go. But I can kind of walk you through very easily what you need and able to basically do in-machine automation for Op1 stock prep. So just kind of pulling up my web browser here. The very first thing that you're going to need is some kind of spindle gripper. Now, there's a variety of spindle grippers that you can use that we manufacture in order to move parts around. Basically, the big thing that you want to know, generally for Op1 stock prep, it's possible to use the Gimbel, which is a vacuum-based venturi system, although we usually recommend going with a standard gripper, standard air gripper, or a coolant gripper for this kind of application. The reason we usually recommend using an air coolant gripper for this application in particular, you really just want to use two tool slots use one tool slot rather than two. Generally, we're going to be using a Gimbel when we're doing a full one-piece flow, automated workflow with two or more operations. So we usually are going to use, for lighter parts, a normal standard Gimbel gripper 4, which has this much smaller profile. That's available in 3-spindle air, 3-spindle coolant, and roto flow link versions. And then for heavier parts, kind of like the part that I'm probably showing you now, you're most likely going to want to use the more versatile high force Gimbel gripper. Now, obviously one question with this is, do you have 3-spindle air or coolant? And the answer is we have a solution regardless of whether you have 3-spindle air, 3-spindle coolant, or neither. If you have neither, we have this flow link system, which you can see here. Basically, this allows the gripper to engage and disengage into our flow link block, which mounts to the bottom face of your spindle. And we have a built-in rotor union, so that we're still able to rotate it. So that's how you're going to handle the parts. You need a gripper. Really, you just need one in this kind of one-op stock prep. And now the question is, how are you going to work hold the parts? Now, with most parts, we're able just to use one of our standard vices. We have an auto vise line, 75, 100, 150 millimeter, or 3, 4, and 6 inches. Generally, most people think they want the 150 millimeter, and in reality, we push the majority of customers towards the 4-inch or 100 millimeter auto vise. It's really that sweet spot of size, and we can always do extended soft jaws if we have bigger parts than that. So that handles your gripper to actually manipulate the components in the machine. That handles your vise in order to do the work holding. And for a round part, we generally are just going to use soft jaws with that round cutout. And then obviously we need something to control the pneumatics that we have here. And one of our philosophies at Gimbel is really to handle the entire solution beginning to end, not just to handle some small portion of it and let you figure out the rest. And because of that, we have the MCodeAir Kit. The MCodeAir Kit basically just plugs right into your machine. There's a 24-volt converter option. If you're on anything that isn't Haas, it's like a 5-minute install, and it provides you 2 different outputs. These are both two-channel solenoids in order to be able to both actuate a gripper on the flow link system as well as your automatic device. Now, if you're using the flow link, you're going to use both of these. If you're using 3-spindle air or 3-spindle coolant, you're only going to end up using just one of these slots. It's also worth noting, whenever we can, we like to use the 3-spindle air variant of the gripper in applications. It's just, we don't want to be spending, an extra $600-700 a gripper if we can avoid it. So we actually push a lot of Haas customers in particular who already have 3-spindle coolant to just go and buy our Equip Flow kit. And the cool thing about the Equip Flow kit, it lets you retrofit that onto your Haas machine after the fact. Now, we've packaged all of this in one convenient bundle to be able to do everything you need for a one-op stock prep. And you can see the prices here, roughly $4,800 for the one-op bundle for air or coolant, or we step up a little bit in price if we're going for the roto flow link system that's able to operate without coolant or 3-spindle air. So we've packaged everything there, and then we've also handled the software. So I can walk you through the software in a minute, but this is really built so that obviously we can turnkey these things to make them work for you out the gate. Generally that's around $5,000 to do, an Op1 component, which we do quite a bit, but we built this so that you're able to do it on your own. So I'm going to show you an example now of how we would handle Op1 stock prep of a round component where we're dovetailing on a Haas VF2 YT. So this was just a quick mock-up. The big thing that we generally see when people are self-implementing one-op stock prep, they massively overthink the tray. They go and make the tray with all these complex features, generally just 2 pieces of laser cut material with some spacers in between from Mastercar. You can just get these from Send Cut Send. It's, relatively cheap. They're super fast. And, basically we're just taking whatever our diameter is and adding, 15 to 20 thou depending on, your stock tolerances. Round stock, very, very easy to do. Probably one of the easiest things. And then obviously we need the work holding. Now, whenever we can, we just use our auto vices. You can use something like an automated, Royal chuck or similar that's pneumatically actuated. That's a good solution, but, generally speaking, this is a really good workflow that's very tolerant to chips. So basically the way this works, we have this tray mounted here, and the only caveat, you can see I have this sketch, and this sketch shows the travels of the actual machine. All of our parts just have to be, the center line of all the parts has to be at most coincident with the center line of that sketch outline that we have here, in this case for the VF2 YT. So you can see here, we can actually move this out, and we could go make the actual tray a little bit deeper, and we could add, example, another row, and, probably like 5 or 6 more columns. But, here we have an 11 by 11 grid. So, we have 121 parts. That's a decent amount of runtime. And, basically the big difference between having something like Mighty Biting, a ton of these, you're just sliding these in to a slot. So the changeover, rather than a Mighty Bite where you have to torque it down or check it, the changeover is incredibly quick. We're talking about a second or so. And then the actual workflow. So, obviously we have the auto vise here, and, we have the tray, again, just, laser cut. Some people machine them. We can even 3D print trays, although this one's a little big to do that. And then we mount our automated work holding, preferably one of our auto vices. And then, unlike the tray, usually what people are underthinking a little bit are the soft jaws. All your process reliability is going to come from the how good your soft jaw design is. All of your precision and repeatability is going to come with how good your soft jaw design is. And really your effectiveness against chips is coming from this as well. So you can see here, like with proper soft jaw design, generally, in this case with a round part, you can see these fillets. These are kind of to guide the part. Spindle grippers are going to be pretty much an order of magnitude more accurate than something like a robot or a cobot, just because we're inherently picking up the accuracy from the CNC machine rather than this external system. But, we still, if there is, for whatever reason, any misalignment, we want to make sure that the thing self-centers. So basically, this would close, obviously, and then, we're gripping our part. So spindle gripper grabs component 1, moves it into the auto vise, and then on all of our spindle grippers, you can see here, there's these little rubber pads. And those little rubber pads serve to put Z preload onto the component. And, generally speaking, for almost all round, oblong, oval, or rectilinear stock, the default universal gripper fingers and pads will work wonders. So, we load the part. There's a Z preload setting on how much, we want to move in Z. And that part gets loaded. And then at that point, the auto vise clamps. And then we go into the machining cycle. We machine it. And then here I have an example of what it would look like, once that part is dovetailed. And then the exact opposite happens. The gripper comes in, we grab it, on a dovetail application. You can pretty much always use the same gripper for both the load and unload, because we still, in this case, have that round stock shape. And then we grab it and we put it back into the same slot. And then what this process is going to do, it's next going to go and clean the vise. So typically, we just are going and spraying coolant with the vise jaws open. And you can see there's this flushing channel that is pretty standard for us in order to make sure all those chips are washed out. Now, almost everything other than Haas has more than good enough coolant flow in order to wash out the chips super effectively. Oftentimes with Haas machines in particular, especially kind of the standard VF line of verticals, we go with a chip fan over everything, and then we do the final coolant washout. Generally, that cycle time there for the chip flow and coolant washout is going to range, depending on your tool speed change, your rapids, and so on, between like 5 and 15 seconds or so. So now that this is washed out, after we put the one back, we go and automatically grab the second one, load it, and rinse and repeat. And just like that, in this case, you would turn 121 of these blanks into 121 of these little dovetail features right here. One-op automation is incredibly easy. You can really learn it in an afternoon. Or if you just really want to get up and go, obviously we'll turnkey this and do the traditional training. So, I just want to show for a second here a little bit more about our semi-turnkey process. This is kind of our standard 2-op automation workflow, which is a little bit more complicated to implement than what you're seeing here with this, 1-op stock prep. But, basically with our semi-turnkey process, we do everything for you beginning to end. And, we're going to implement it, test it, and validate it on our machines. And then we send the whole thing over to you and do the 3 Zoom training sessions, as well as, have an additional 3 hours of support there. We set up a Slack channel so you're able to instantly communicate with us. And it's a very efficient process overall to get implemented. We have people getting implemented on complicated 2-op turnkeys in as little as 2 or 3 days. And the 1-op turnkeys, people are usually literally within a couple of hours implementing. Now, if you don't want to go the semi-turnkey route, again, for kind of a stock prep operation, it's about $5,000, which would be on top of the $5,000 in hardware. Instead, you can just use a programmer. So we have versions of this that you can import. There's an import existing file. We have versions of this that you can import for a whole variety of things, and or for a whole variety of machine brands rather. And what's really nice about that, we can just give you the brother variant, and then you're able to basically instantly set everything up. So going in a little more detail here, we have an 11 by 11 pattern. So let's just put that information in and show you how to use this. By the way, there's also a training article and training video on how to do this. We have our tray work coordinate system. And basically we set that WCS where it'd be center bottom of this 0, 0 position in the matrix. So, we would probe this bore in X and Y, and we'd probe this surface in Z, and we'd set that WCS to G55. And then the X pattern distance and Y pattern distance, we just insert as numbers, 1.75 by 1.75. And then for this, if you have a Haas vertical, VF style machine, all this code is correct. There's very little changes, but there are slight changes that we go and add in. Here's our chip clearing code that goes and turns on a chip fan. And, notably the chip fan's on T1 in this example. And then basically we take your existing machining code, and this is really key to everything we do. We're not asking you to figure out how to do the machining on your own, or how to do all the spindle gripping moves on your own, rather. Instead, we're just asking you to take your machining code. Basically, in this case, you delete out the O number because it's done as a sub-program versus our more complex macros we do with turnkeys. They're actually G65'd out. We delete your O number, we delete those percentage symbols, and we change the M30. We just delete the M30, and there's an M99 here. And then all we do is generate program. And just like that, on a VF machine, literally all the code is handled for you. So regardless of how we do it, whether it's with our more complex 2-op macro templates, or if you're doing it on your own with a program generator, the entire point is that you're never having to control a gripper. There's not much to learn. So, basically in summary, the 1-op automation stuff, it's incredibly easy. A turnkey, you can mount the stuff and get it running in an hour, or a semi-turnkey rather. Or, when we're going and doing implementation on our own, it's not uncommon for customers to go beginning to end of a project in 6 hours or less. Obviously, you got to coordinate. You need to design the tray, probably send it off to send, cut, send. Almost the majority of your time, the first time you do this, will be making the soft jaws. You can kind of see the soft jaw design, putting in some flushing, making sure that things are relatively self-centering. That's going to just up your process reliability, several fold. And then there's other tricks that we can put in here that we have, kind of standard macros for, such as just going and probing every part. And even in Fusion, you can just go and set it to probe every component and throw it. Basically, you probe the Z on just a random different work offset. And if it's out of tolerance, then we can throw an error. So we're also able to live catch if there's any issues whatsoever with the spindle gripping system, which is incredibly rare. I mean, we're talking about a pneumatic end effector that goes into the machine. We're basically picking up the process reliability of the machine itself. But, in this example, we can go from, maybe somebody has 3 curve vices and they're doing 2 of these per vice. And we can go from a very, very short cycle time of say 5 minutes for max for doing 6 of these dovetail features to now we're able to go and run an 11 by 11 grid. And again, we could actually make this bigger. We were fully optimizing. We would kick this vice over, go and add an additional row, probably 4, 5, 6 more columns. And we can still stay well within the travels on this machine. And, this can potentially let you run a huge amount of stock, through the night, or in a lot of cases, maybe even through the weekend if you have a hardware material. Usually 1-op automation for stock prep, huge slam dunk. And one thing that people don't think about a lot, this is freeing up your more expensive machines, your machines with a 4th axis or a 5-axis trunnion on them, or an entire 5-axis vertical machining center. And having the ability to process this on a lower value machine and then only do that high value work once the parts are actually dovetailed and prepped on that higher value machine really can let you squeeze a lot more value out of all of your machinery and keep those spindle times, allocating the most expensive spindle time to the highest value money-making procedures rather than, these lower value ones that should really be done on a simpler VF2 or, Okuma 3-axis or whatever style machine you have. So that's all I've got for today, but I just wanted to put together this quick video on, what a standard kind of one-op stock prep workflow looks like. And of course, these trays, by the way, just one final note, they're applicable with changes in Z. So, we can put a taller or shorter component in here as long as, we select the right spacer. And then generally speaking, we do have a universal tray, but it's not nearly as space efficient. So if you have really high density like this, generally you're just going to make a new top tray, just laser cut it, send cut send. You're going to spend $50 on the piece of material, and then 6 bolts, and then you're off and away. So super simple process, super fast ROI, and it's something you can implement yourself. All right, thanks so much.